All right, now we're looking at lesson 2.7, graphing inequalities. This is the last lesson for unit 1 and 2. To graph linear inequalities, it's going to be really similar to graphing linear lines. Okay, we've done this before. This should be review, but let's go over an example to see what this looks like. If we need to graph this inequality, x minus 2y is less than 4. Notice it's not less than or equal to, it's just less than. These are the steps we're going to take. Now these steps should be the same for any time we're graphing linear inequalities. Remember, linear just means they make a straight line. We can tell this will make a straight line because there's no exponents with our variables. Also, we don't have like something over x or something over y. It's just things multiplied by x and y. Okay, so our steps to solving an inequality like this. We're going to change it to a y equals mx plus b form, just like we want to do with any linear equation. We are then going to graph that line, starting off by using dashed lines. Okay, starting off, we're always going to use the dashed lines, and then we'll fill them in either with the solid line or leave them as dashed. The solid line will be if there's an or equal to. So if it has the underline, then we'll fill in the solid line there. So again, step 3, if the inequality has the or equal to, that line underneath, that's when we would fill in the line. The last thing we need to do is shade on one side or the other. To do that, you can pick a test point and test it in this inequality. If it works, you're going to shade that area. If it doesn't work, you just shade the other area. All right, so let's see how this works, how this one pans out. We have x minus 2y is less than 4. That's where we start. So first, we're going to subtract x from both sides. Get rid of it here. Put a negative x because it was subtracted right here. So negative 2y is less than negative x plus 4. Now, on both sides, we need to divide by negative 2. Because y is alone next to this negative 2, we're dividing everything by this negative 2. When you do that, watch out, note that this sign flips. Whenever you multiply or divide by a negative, the inequality sign will flip. So instead of this negative 2y being less than negative x plus 4, it's now positive y all alone is greater than, because the sign flipped, 1/2 x minus 2. Now remember, when this says negative x, it's actually saying negative 1 times x. When we divide it by negative 2, we can do, on just this term, just the negative 1 divided by negative 2. Negative over negative is positive, 1 over 2 is 1/2. Okay, then just with this term separately, positive 4 divided by negative 2 is a negative 2 or a minus 2. So this right here is the equation we are looking for. Y is greater than 1/2 x minus 2. So what that tells us is we start at negative 2 right here. We're going up 1, right 2, up 1, right 2. So we'll plot a few points. Up 1, right 2, up 1, right 2, up 1, right 2, and so on. Okay, now we will start with our line. Go right there. We will leave this one as a dashed line because it does not say or equal to. If it was or equal to, we have to fill it in as a solid line. Now the last thing we need to do before we can shade this is test a point. We are going to test the point 0, 0. Now how do we test it? We actually plug this back in to our original equation. So it was x minus 2y is less than 4. So we'll plug in 0 for x, then minus 2, or this 2 is being multiplied by y, which was also 0. And our inequality told us that that should come out to be less than 4. So let's check and see if this is. 2 times 0 is 0. 0 up here minus 0, is that actually less than 4? Well, 0 minus 0 is 0. Is 0 less than 4? Yes, it is. So because yes, that is in fact less than, we are going to shade on the side where that dot was. So where did I need our highlighter one now? We will be shading everything on this side of our line. And remember, technically this is saying the points on this line do not count. Okay, these ones don't actually work, but all of these ones do work. Everything in the shaded area does count as something that would make this inequality true. We're going to look at another one in kind of a word problem form. On this one, I'm going to show you a different way to shade, or a different way to find a point that works or a side that works. So for this example, we're going to read our word problem. The SAT has 2 parts. This is a little bit older. I think it actually has 3 parts now, but back then it had 2 parts. Now there's a tutoring company that advertises it specializes in helping students who have a combined score of 900 or less. So first we're going to write an inequality to describe the combined scores of students who are prospective tutoring clients. So students who this place would help out. Notice that on this little chart, this little graph, math is on the x-axis, verbal, those were the 2 parts of the SAT, math and verbal scores. Your verbal is on the y. So for our inequality, our math plus our verbal has to be less than or equal to 900. Now, in our terms, math was x, verbal was y, so we would say y plus x is less than or equal to 900. Take your 2 scores and add them up. If it's less than or equal to 900, we can help you with this tutoring place. So now that we have our inequality, we're going to look at the bottom one here. We need to graph it. So again, like before, we're going to change it to slope-intercept form. So start with the inequality, subtract x from both sides, and we now get y is less than or equal to negative x plus 900. So from here we need to graph. This 900 means we're starting right about here, 900. This negative, remember there's kind of a hidden 1 here, negative 1 means we're going down 1 over 1, down 1 over 1, down 1 over 1. We're going to do that all the way throughout from here all the way down until we hit 900 over here. I'm just going to put my 2 dots here first before I draw in my line. Now again, we would normally draw in this dashed line. Instead of doing that right away, I'm going to say, look, I notice that this is the or equal to. So instead of drawing in that line, I'm going to right away draw in a solid line. Because I know, because of the or equal to, this needs to be a solid line. Now to shade, I can test my point 0, 0 right here. And yes, if I add 0 and 0, that'll be 0, and that is less than 900. So I should be shading everything below this line. Now another way to check it, once you get it into this form, this y equals mx plus b form, pick any point on the line. So I'm going to pick this point right here, kind of in the middle of nowhere. Now since it says y is less than or equal to that, we go in the y direction, so up and down, that's our y-axis. We want less than, so we go straight down from this point, which means this is the area that should be shaded. Everything straight down. So I'm going to use my highlighter. You can shade it with your pencil. And I'm going to say this is all of the area then that needs to be shaded. Everything below our line. So that would be how to graph and then shade that inequality. This question also asks us then, does a student with a verbal score of 480, actually I'm going to get this out of the way. This was just that trick. If you're using y equals mx plus b, pick a point. Y is greater than means shade up. Y is less than means shade straight down. Now the question asks, does a student with a verbal score of 480 and a math score of 410 fit the tutoring company's guidelines? Instead of trying to figure out exactly how that works, let's just find that point. So we go to a math score of 480, which is about here. Verbal score was 480, which is about here. The math score would have been 410, which was about right here. So we find where those two meet, here and here. That would put us right at about this spot. Notice that that spot is within our shaded region. If we wanted, we could plug these into our original inequality, but we can also see that that dot is within our shaded region. So does this student fit? Yes. We know that because the point 480 and 410, actually these would technically be flipped around, 410 and 480, because 480 is our y value, the verbal, 410 is our x value, the math. That spot is within our shaded region. So yes, this student would fit the guidelines. The last example we're going to look at is how to graph absolute value inequalities. So to graph an absolute value inequality, first we treat it as though it was just an absolute value line. So you use that y equals a times the absolute value of x minus h, all of that then plus k. So as long as it's in that form, it's ready to go for you to check. If it's not, or if you don't like using this form, you can always use a table, an x and a y table, and plug in enough points for your x and then solve for y until you see a pattern. Once you've seen that pattern, then you can just plot out your absolute value from the table. When I show it to you now, I'm going to use this. Okay? When you have it as y equals a times the absolute value of x minus h, then all of that plus k. Remember, each of these pieces tell us something. Here is our stretch and direction. And then here is our vertex between h and k. So, as we have it written out, if there's nothing in front of this absolute value, that means it's being multiplied by 1. It's saying x minus 2, so h is 2. There's nothing behind it here, so our k value is 0. So this is what our line would look like in kind of that standard form. What that's telling us is our vertex is at 2, 0. So I'm going to go ahead and plot 2, 0. That's our corner piece. Remember, all absolute values will draw a V-shaped graph. This one, the point, will be at 2, 0. And we know that because it's right here. We're subtracting 2 and we're adding 0, so it's 2 and 0. What else does this tell us? Well, because our 1 is a positive, our V opens up. It's a regular V shape. It's going to look like this. Now, moving away from this vertex, what is the slope? Do we know if it's going up 1 over 1, up 1 over 1? Maybe it's going up 4 over 1, up 4 over 1. Maybe it's going up 1 over 3. We don't know yet. But we can just look at this a value, because the a value is 1. That means the slope on each side of our vertex, as it makes a V, is 1. So we're going up 1 over 1, up 1 over 1, up 1 over 1, and so on. Same thing in the other direction, going up 1 over 1, up 1 over 1, and so on. Technically, this means this side, the line has a slope of -1, and on this side, the line has a slope of +1. Okay? But we know that this has to open upwards because our a was originally positive. So it has to look like this, not like this. So we have all of our points. Well, I guess we have enough points. We can see what our absolute value graph should look like. Now we just need to draw in our dashed line. Well, we have to decide, is it dashed or solid? Because this is greater than or equal to, instead of drawing that dashed line and fill it in, we can just go right for drawing a solid line because it says or equal to. So solid line that way and a solid line that way. So here's our absolute value line. Because it's an inequality here, it says y is greater than or equal to that, we should shade one region or the other by testing a point. We're going to test 0, 0. It's a nice easy one to pick because it's not on this line. If it was on the line, it wouldn't make sense to shade it or to use it to test. But since it's away from that line, that's a good one to test. So we just plug in 0 for x, so right here, and 0 for y, so right here. And we need to check and make sure that that statement is true. So 0 is greater than or equal to the absolute value of 0 minus 2. Is that true? Well, to check, 0 minus 2 is negative 2. The absolute value of negative 2 is 2. Is 0 actually greater than or equal to 2? Well, no. No, it is not. So, we know not to shade on that side. We should be shading everything over here. This should be the area of the line that we shade. Now again, like we did before, we can also say, because it's saying y is greater than all this, we could also just pick a point and go in the greater than direction for y. Straight up from there. Okay, straight up from here. Straight up from here. Okay, if this said y is less than, we would pick a point and go straight down. But this is greater than, so it's everything above. So as we shade it all in, it's going to be this region, this area, everything that is above that V. That would be graphing an absolute value inequality.